Hi, this is the second in a wee series of kind of Grasshopper basics tutorials. This one's a nice little example that introduces domains, kind of random numbers, and also the graphed feature, which allows data to be matched, and this. We'll also experiment a wee bit. We'll actually look at the Graph Mapper component as well to get even more kind of a different patterns of numbers, you could call it. So this is the kind of the end result using random number generation. So it's a surface that we subdivide, and then each cell gets given a different extrusion depth, and we can influence this in all sorts of ways. So have we look at the definition. It's quite small, it's quite tidy. We bring in the surface, and the surface in this one, we're just going to show you how you attach a geometry from Rhino. So the surface is coming from Rhino. We set up the subdivision, and so we've got controls over how the subdivision works. So we've got parameters we can vary there. The deconstruct component allows us to get to each of the cells that this has been broken into, this has been subdivided into, and it creates a box on that, but the height of the box, the value for that is generated in this area. So we're setting up a domain of numbers, a kind of a what would you call it, a kind of a boundary of numbers. The numbers can't be less than 15 and they can't be more than 450. So that's what it needs. It needs that range to work with. The list, the number of values, that comes from the divide domain component. So it just says how many cells have we divided the surface into. Use that for the number of values to generate. So we don't need any more than we've got cells for. Okay, and seed is really just a starting number that gives us a kind of a different set of random numbers. So you can have this slider as long as you want, and it will generate a different set of random numbers. But these are kind of termed pseudo-random numbers. So if you want to have a wee look at that, check this link and you can read up on that. As you know, they're not purely random numbers. There is a bit of maths behind that to generate these numbers. Okay, so this is just looking at the values that come out of that. This goes into the height for each box, and as you can see, coming out of here, there is just a single list. So it's just a list of numbers, and so, but coming out of the deconstruct brep, we've got a tree of data. So if we don't match the type of data going into the box command, it's not going to behave the same. We'll just get the first value assigned to everything, which we don't want. We want each of these values to get assigned to each branch, and that's what this tiny little component here does. If I zoom in on that little symbol there does all the work. So that's going to graft the numbers, so each value here gets a different number grafted onto it. Okay, and the very last bit here is just to change the color of the objects. It's called a custom preview. It just kind of applies shading in Rhino that makes the objects look a bit more, you can kind of understand the geometry a bit more if you do use that. So here's the definition in working. So we've got a surface at the back there. It's kind of flickering because it's kind of doesn't know which bit geometry to display. Okay, this is how many subdivisions we want. Okay, in each direction. Okay, down here we've got the maximum and the minimum for the extrusions. So if I put this up to the top, you know, everything's the same. Okay, if I put this to the bottom, everything's the same but thinner. Okay, so we've got any range in between those. We can have the seed here just generates a different set of random numbers. Okay, and then the graft component. If we don't graft, boom, we just get all the values assigned to every single box. There you go. So it's just kind of a crazy kind of set of numbers going in instead. So graft sorts the data out, and we get the pattern that we were anticipating. Okay, so let's build this one up to start off with. So let's just scribble that, and I'm going to start Rhino again. So on a new file in Rhino. Okay, so we'll start with large object millimeters. Okay, and then just in the front view, I'm going to use, from the Surface Tools tab, I'm going to use Surface corner to corner, rectangular plane, corner to corner, and we'll start at 0, 0 there, and then it's at 3600, 2400. So 3.6 meters wide by 2.4 meters high. Enter. Okay, so there's our plane. There it is in the shaded view. Okay, so we need a container for that. So that is a surface. So we use the surface component. Okay, I've got bifocals on. Okay, you can also use sunglasses. That's another one that you can download. Okay, so this is waiting to receive an object from Rhino. So if you right click it, set one surface, click that. This doesn't need to be shown now if you don't want to. So you could either switch the default layer off, or you could hide, use the hide command, and we've just got the Grasshopper preview then instead of the Rhino one as well. Okay, next command, got divide domain squared. So here we go, divide domain squared. Okay, that needs the surface, so the base domain is the surface. Okay, and then it's needing how many values do we want in the U direction and the V direction. So these need to be whole numbers. Okay, so don't use a decimal on these. So let's just say we'll have 1 to 24, 1.24. So I'll use that twice. So copy it and paste it in again. I'm going to set this one to 8. I'm going to double click this, set this one to 12. Okay, so put that into the U, put that into the V. Okay, and then the isotrim command. Isotrim showing 2 there. I think one of them might belong to a different plugin. Let me just check. So Control Alt V. That's okay. That's the Grasshopper one. But watch out. Sometimes icons get kind of hijacked by other plugins. We don't want to use the wrong one by accident. I've got loads of sliders here. What have I done? I've gone and dropped in 100 sliders somehow. That wasn't supposed to happen. Good. Okay, off you go. Okay, so the domain, the input domain here is coming from divide domain, and the surface gets plugged in as well. So that's quite a common routine that you'll see in all sorts of definitions for splitting something up. So we can see here we've got a bit of a kind of clash of geometry again. Okay, because this generates another surface. So you don't need to see the preview of this one now. Okay, just keep it kind of a bit easier to see. Probably only need the perspective viewport now as well. Okay, so it's nice and small, this one. So next up, we need to isolate each of these surfaces. So that's what deconstruct brep can do. Let me see if it's up yet. Not yet. Deconstruct brep. Eventually it comes up. Okay, so this is what's getting deconstructed. Again, we're doubling up on the surface, so we can hide the preview on this one. Okay, so here we've got what we call a tree, a data tree. So let's just have a wee panel on that so we can see what it looks like. Okay, oh actually the faces, not the edges we want to be looking at. Okay, so even though there's only one surface in each of these branches, it's still a data tree. Okay, so when we put numbers to these, we want one value to go to this surface, one value to go to this one to go to this one. Okay, we don't want all the values to go to each one, we just want one per item. Okay, so let's get our values now. So we need the list length, we need to know how many values are coming out. List length, there we go. Okay, and we've got 96 coming out. Okay, we don't need to make a note of that, we can just let that feed in a second. Okay, we're going to use a random number generator. Okay, so if you just search for random and you're looking for Schrodinger's cat. Okay, so the n is the number of values. Okay, so that's already chucking out some numbers. Okay, based on 0 to 1, so it's just given us 96 random values between 0 and 1. So we can't just use those because they're not big enough. They're tiny numbers. They're all less than 1 millimeter. We'd not be able to tell anything that's happening. We need something a bit meatier to go into there. So we need to set up a different domain. Okay. So we want the domain command, and it's construct domain, this one here. Okay, construct domain, and it just needs fed 2 numbers. As it stands, it's 0 to 1, so it's pointless plugging that in because that's 0 to 1 already. That's kind of hardwired into it. Okay, we want a domain that's going to go from 15 millimeters to 45. So let's put a slide, sorry, 450. So let's put a slider in that's definitely up to 450. Okay, so we can limit that to 450 if we want to. So we can say maximum 450. If you double click it, you can do that. Doesn't matter if these are integers or fractions because the numbers coming out are going to be split up. But we'll say we'll go for real numbers in just 1 decimal place. Okay, but the numbers coming out are going to be quite a bit more accurate, I think. Okay, copy that into this one. Actually, no. Let's say we do want to limit this. Let's tweak this a wee bit. Let's say it's got a minimum value of 15. So let's keep our range correct. Okay, so it only goes from 15 to 450. Okay, so pop those in. We'll put this one down to 15. Okay, so we should have a range now of 15 to 450. Okay, pop that into here. Okay, our values now are more usable. Okay, we don't need to see all of this. Let's just make it a little bit smaller and pop it up here. Okay, now we need the box rectangle component. There we go, box rectangle. Okay, so the rectangle is going to come from the face, so that's looking good. Something's happening. We don't need to see the deconstruct rep now. Okay, but the heights of these are a range of 0 to 10. Okay, now if I zoom in on this, can we see any thickness? There is a bit of thickness happening there, but it's not as dramatic as we want. Okay, so we only want this to operate in the Z direction. So unit Z. Okay, if we plug that in just now, we're getting even smaller values going in. If we plug our random values in, okay, something's happening, but we're seeing basically the 450. So we're getting a a lot of boxes, but it's not breaking up the values. Okay, so if we zoom into this, and we can add the graft switch, okay, which you can also do as a separate component. If you just type graft, okay, it can pass through this and it will do the same operation. Okay, so this is nice to see because it's nice and big. You can see the component, but quite often it will just be done as a switch in here. Okay, so let's plug that straight through. Okay, it does exactly the same job. So you notice now that we've got a tree coming through, and as long as they don't have to be the same length necessarily, because you will find that it'll kind of repeat the cycle again. But we've got, because we used the list length here, we've got the same number of values going into matching the values coming through here as well. So this is what the data structure looks like before it gets grafted. So it's an individual list, individual values. Okay, but after the graft, each number goes into its own branch. Okay, so these references here don't necessarily have to match, it's the structure that has to match. So you're seeing it's in a similar format. Okay, so that's quite cool. It's all a bit transparent, a bit see-through, so it's not quite easy to see, and that's why we can use the custom preview button. So custom preview, here we go. The default color is a kind of a bit of an off-white, so it's kind of a bit pinky white. Okay, if you want to put your own color onto that, you put it into here. Okay, and you use the swatch component, color swatch. Okay, so if we put that in, we're going to get a white wall. That's quite difficult to see as well. Double click the color here, and you're using the standard kind of color selector in the software. So that's where shall we go? I used a kind of a tealy type color. That looks quite good. Okay. Now we've got parametric control here, but the randomness, if we add a slider to the seed input, we can get a very different set of random numbers. So this slider doesn't have to be too long. Maybe go from 1 to 10, 1.10. Okay, if you put that on, this is how you kind of change the randomness. Okay, so that's the main example finished, but just want to take a little diversion. And okay, so while I've got your attention, I'll just show you another way of generating numbers, but they won't be random. This will be more a kind of a pattern for the numbers. So if we use the Graph Mapper, let's place it here, let's pull this down a bit, and if we right click that and choose a graph type, I'm going to go for sine because it doesn't influence the numbers too much. We can kind of keep them without them getting exaggerated. Something like the parabola shape tends to exaggerate the curve, so the numbers. Okay, so these are the input values along the x-axis, and the output values are on the y-axis. But kind of imagine the y-axis is at this side instead. So here, if we put a value of 0.5 in, we get a value of 0.5 out. So let's just draw this on in a different color. Okay, so 0.5 in gives you 0.5 out. Okay, 0.3 in gives you 0.2 out. Okay, so you're getting that kind of cumulative shape. So the numbers are kind of going up in a curve and then tailing off in a curve. Okay, if we adjust these points, we can have a more kind of pattern in the numbers. Okay, so a 0.5 in still gives us a 0.5 out, but a 0.3 in is giving us less now. Okay, 0.4 is creeping up, then we go up to 5, and we can have as many values as we want in each of these directions. So for us, we need to kind of set this to work for the values we're thinking of. So we've got 96 numbers. So if we double click this and say that we have our x-axis is going to go from 0 to 96, sorry, 95, because it's 96 numbers, 0 to 95. Okay, and the y-axis, this is going to be our 15 millimeters to 450. So that's our range. So you can see let's change these numbers in the corner. So that's our domains for these numbers. Okay. Then we've got nothing coming out because we haven't got anything going in yet. So it's not got any numbers to work on. So if we use a series, okay, the start number is 0, that's fine. It's going to go up in ones, that's fine. But the count is the number of numbers, and we can hijack that from the list length. Okay, so now we've got 96 numbers coming out, 0 to 95. We'll put that in. Okay, so you can see what's happening here. It's going from the first value there is 390, creeping up a wee bit. We're getting to a maximum of about 430, and then it's coming back down. Okay, so round about here, what would that be? Say around about 30, value 30, we should be nearly down at 0. So we're getting to the lowest point there, yeah, so about 33, we're down at the lowest numbers. So it all depends on where these points are, what happens to the numbers. So you get very fluid kind of number distribution. Okay, so pop that in instead of the random, and the grafting is still needed. Okay, so we get quite a different pattern. It's quite interesting, but just watch the wall as you play with the graph. So it's quite, it's, what would you say, it's kind of, what looks good to somebody isn't going to look good to somebody else. It's not very objective as such, but it's quite good fun, and different graphs will have different results, but I think the sine one works quite nicely because of the kind of the repetition of the pattern. Some of the other ones are a bit haphazard, different graph types. A lot of them make the numbers too big. See what happens when you put parabola in? Let's see, is it going to behave? Oh, it's doing okay, yeah. But if we go too far, you see it's kind of multiplying the numbers too much. Okay, so if we keep it in a reasonable range, it works okay. But I think you'll find sine kind of behaves best. It gives us that kind of fluidity that we're looking for. Quite cool. Okay, so that's a reintroduction to the graph mapper. Quite often you're basically kind of keeping it at the 0 to 1, 0 to 1 kind of domains, but for this one we need the numbers to be in our proper range that we're working to. So let's make it a little bit more exaggerated. Nice. Okay, hopefully that's pushed you on a little wee bit further. Each definition you always pick up something new. So see you next time.